So good morning. So first I would like to thank the organizers to have given me the opportunity to make this presentation. And I see there are interesting discussions also for the afternoon. So now, before lunch, this presentation, which is in fact giving views on what EFSA has done in the area, in the cases where EFSA has used TTC, and of course challenges and perspectives. And as we heard already a few minutes ago, there are still a lot of challenges on our table. So yeah, first warning, I'm not an EFSA staff, so any view which I could present is strictly my view, even if it's taken from EFSA. If some sentences are taken from EFSA website, I try to be as close as possible, but I may sometimes misinterpret, so please be cautious with what I say. So just to summarize where we are with the TTC, we have different thresholds. We have seen from the overall strategy presented by the different speakers. Two speakers today have presented the overall strategy. Here below, you have the three Kramer classes, the ones of Munro, the ones of Kramer, of course, and of Munro in 1996. But you heard already that since there are more categories which have been added for neurotoxicity, the organophosphates and carbamates, and you also have alerts for genotoxicity, and you have substances for which the TTC approach cannot be applied at all. So we have all these categories now, and they are organized in the overall exclusion strategy. Also, you should take care that sometimes it's expressed in milligram per person per day or in microgram per kilo body weight per day, and the recommended value is to use microgram per kilo body weight per day. So my presentation will be divided with three questions. Examples in the two first questions. For which substances is TTC used already as a tool for risk assessment? Second category will be the limitations, of course, and the challenges and perspectives for the third question. So let's start with the substances, the examples for which substances are evaluated using the TTC approach. In the work of EFSA, it was used in 4 areas. I will only discuss the 3, show examples from the 3 first. Flavoring substances, non-plastic food contact materials, food and feed contaminants, toxins, and pesticide metabolites. So first, flavoring substances. So it's also a decision tree. You start with the question, is a substance genotoxic? If yes, then there is a safety concern. And in general, the conclusion would be that the substance should not be used. If it's not genotoxic, then you look at the metabolites. If there is no toxicity associated with metabolites, you look at the TTC. You compare the daily intake with the TTC value. And if the intake is low, then you could say that, at least in the case of these new flavoring substances, that the use of the substance is acceptable. However, if the answer to the 2 previous questions is no, then you need more toxicity data for the first question. And for the second question, you need even more toxicity data. The purpose of this presentation is not to discuss this toxicity data, but really to emphasize what I would call my take-home message number 1, that for risk assessment, the TTC approach is often integrated in a strategy which makes use of other data. It's seldom that you just use the TTC as such. It is integrated in an overall strategy. Here you see, well, you take into account genotoxicity data, data on metabolites, etc., and other toxicity data. The second case was non-plastics food contact materials. This is also a different situation. It is not yet applied. But this area includes coatings, paper and board, rubber, colorants, wood and cork. And as you know, some of the substances used in this area have been responsible for crises in the recent years. You have the names of NODG, ITX, methylbenzophenone in mind. And all these substances are non-plastics. So you know well the evaluation of plastics. You have good guidelines, and that will be also shown this afternoon by Claudia Heppner. But for the non-plastics, you have not much. What you know is that you have more than 3,000 substances which are used in the different member states or inventoried in the different member states in their different regulations. And this was found by a working group set up by EFSA in 2011, and a working group of delegates of member states. And they were appointed first to see what's the situation and to propose solutions. And the solutions they proposed were of two kinds. First, that they said, we have 3,000 substances. We cannot go substance by substance, make all the typical evaluations as we do for plastics. You know, for plastics, you evaluate substance by substance. If you have 3,000 substances on your table, it's not possible. So the first part of the work must be done by industry, because industry should set priorities for the future evaluations, and this should be done based on different sets of data, technological interest of the substance, also probably economic interest, the uses of the substance, of course the TTC, because it provides a quick evaluation of the toxicity, estimated exposure, and of course only industry can do that, because only industry knows the technological interest, only industry knows the uses, only industry can have a view of estimated exposure. So this work is being done, and I know that, for instance, for printing inks, much work has already started in some member states. The second area where the TTC approach could be useful is for agencies if they have to provide what we call a preliminary advice in case of emergency situations. So, as said before, TTC is not 100% response, but it can help if you have no data, if you have to provide an advice, if you have to see whether a substance is likely to be toxic or not. You could use a TTC approach, but of course you can use whatever you have available, read across, if by chance similar substances have been already evaluated. And of course, you have to use conservative exposure scenarios. So this has been proposed for the moment, not yet endorsed, but still discussed by the risk managers. So another case for a bit a specific example with Alternaria toxins. They may contaminate cereals and seeds and cause plant diseases, but the chemical structure is well known. I have shown here the major components of these toxins. There is much which is known. Alternariol and its methyl ether, tenoazonic acid, and tentoxin are major components. And much less is known about the toxicity of these molecules. So in these cases, EFSA used, for instance, EFSA used TTC for their evaluation. For instance, for tenoazonic acid and tentoxin, there was no suspicion of genotoxicity. It was seen that the estimated exposure using a conservative scenario was well below the TTC of class 3, to which these substances can be allocated, and the evaluation was based on these considerations, and that it was said that these substances are unlikely to be a human health concern. Unlikely because there are not many data available, so you cannot be sure that it's of no concern, but you speak of that we say that it is likely. For the other substance, there were in vitro genotoxicity data available. They were positive. And in this case, the dietary exposure threshold was compared to the threshold for genotoxic substances, which I've shown in my first slide and which you have seen already several times today in the overall strategy. You know, the slide which nobody can read. And then the conclusion was that there is a need for genotoxicity data. So again, what I want to show from this example is that you can use the TTC. It can be useful if you have no information and at least no information on toxicity, but then you need at least information on dietary exposure. And you do not use the TTC approach alone, you use other data. So let's go to the limitations now. When and why can the TTC overall strategy not be used? And again, I have 3 examples. One with the exclusion categories. Second with pharmacologically active substances. And the NIAS. So, and I have given 3 reasons. Toxicity reasons, background databases, insufficient background databases, and legal limitations. So let's start with the exclusion categories. So in the overall strategy, the first question is a substance member of an exclusion category? And if the answer is yes, the approach cannot be applied. So I just show, this is here, is a substance a member of an exclusion category? And if the answer is yes, the substances require a non-TTC approach, which you can see again by focusing on the first part of the decision tree of the overall strategy. So the exclusion categories, in fact, you have 2 kinds of substances. You have substances suspected of very high toxicity because they have some structural features which are similar to those of toxic substances. And you have substances which are not represented or not foreseen in the Kramer database or in the Munro database. For the first group, high toxicity, you have high potency carcinogens, steroids, substances known or predicted to bioaccumulate. For the second group, you have the second group which are not foreseen in the databases. You have nanomaterials, radioactive substance, inorganic substance, metals and organometallics, proteins, and I think I forgot mixtures, but mixtures are also not, you cannot evaluate them in the same way using a TTC. Second category, pharmacologically active substances in food and feed. This is a sentence taken from an opinion of a contam panel on pharmacology on these substances. They said that the TCC concept was considered not applicable for this case because some substances which are common in the area are excluded from the TTC approach. And they take the example of steroids. We have just seen that steroids are members of exclusion categories. So they cannot, because they have many steroids, they cannot apply the TTC approach. And they also say that the database underlying the TTC concept contains a small number of pharmacology active substances. So this is another limitation. Last limitation, the NIAS for food contact materials. NIAS stands for non-intentionally added substances. And in fact, the substances for food contact materials are evaluated using a very detailed guideline approach. But often there is no information on the impurities and the degradation products. And these are the NIAS, because you don't add the impurity, you add the substance, and the impurity is also present at the same time. And I show an example of evaluation of a process stabilizers. No, I am not challenging any evaluation, but I show one evaluation which was made 5 years ago, and I apply this to the same situation, the TTC approach. If they had applied the TTC approach, they would more or less reach the same conclusion, but with a different wording. This is an antioxidant which was evaluated in 1998 by EFSA, so with a modern evaluation approach. This is a long chain, but there is an impurity which is just with one methyl group instead of the long chain. And what experts did at that time was to consider that the impurity was chemically related to the substance, and it considered also that it had a low migration. The migration of the impurity was available, and low migration, low exposure, and therefore it's not considered to be a safety concern. If they had applied the TTC approach, they would see that the substance would be classified into class 2. So, okay, I know that class 2 is challenged, but okay. And class 2 corresponds to a threshold of 0.54 milligram per person per day, to be compared with the expected exposure which was determined, which was available in the dossier of the substance. And you see that you reach the same conclusion that the substance is acceptable, but in a more quantitative way. So you can say that there is no safety concern. You don't change the conclusions, but it's presented a bit differently. However, you cannot use routinely the TTC approach, and this is bound to the regulation, because in the regulation for food contact materials, it is clearly said that any potential health risk in the final material or article arising from the NIAS should be assessed by the manufacturer in accordance with internationally recognized scientific principles on risk assessment. And is TTC an internationally recognized scientific principle on risk assessment? That's a question, and maybe that's why we are here today. Maybe we get the question tonight. However, more for the NIAS itself, it will be the focus of the it will be one of the topics developed today by Claudia Heppner, so we will learn more this afternoon. So I now turn to the last part of my presentation, challenges and perspectives. And could the TTC principle become an internationally recognized approach? So I will not discuss all the issues which were discussed this morning. Maybe there is some overlap. I will discuss something, I will in fact discuss briefly accuracy and spend most of the time which is left to me to discuss conservatism of the approach. So we must know that it is not a QSAR method. It is not aimed at predicting, and we know it already from a speaker this morning, it cannot predict an ADI. And I take an example from the database of the food contact material substances evaluated by EFSA, or Scientific Committee for Food, since 20 years. So modern risk assessment methodology. And the conclusion is clearly that there is no correlation between TTC and NOEL. And that's quite clear from if you see the picture. Here you see the substances classified by increasing NOEL. You have in red class 3 and in black class 1. And you see that there is a complete overlap of the distribution. And that's not surprising. All the ones in red have the same TTC, and all the ones in black or gray have the same TTC value, which is different from the previous one. So you have absolutely no prediction, no correlation between TTC and NOEL. No prediction. You cannot predict an ADI using the TTC. That's not the purpose of the game. So this being said, I would like to shift to conservatism. And in fact, to see about conservatism, we have to go back to the definition given by Munro himself of the TTC. He took, for the definition of TTC, the 5th percentile. Sorry, you have already seen this figure 3 times today. The 5th percentile, on the basis of the 5th percentile of the cumulated distribution curve, which means that more or less 95% of the substance have an OL above the threshold, and they are evaluated in a conservative way by the Munro approach. But what about the remaining 5%? So going back to this figure and focusing on the low range, what happens in this range? We are the substance. What are the substances which are here in this area of the distribution curve? And in fact, they are the most toxic because they have the lowest NOEL, while the TTC is higher than their NOEL, which means that if we didn't know anything about their toxicity, and if we had only the TTC to evaluate them, we could be sure that the TTC approach would not be conservative. And I anticipate a bit on my conclusion, because here many of these substances are members of exclusion categories and of the groups which have been defined later than the work of Munro in 1996. So what we can use here is just a ratio of the ADI or TDI over the TTC. I simplify because it's I don't take into account body weight, just for simplicity, to see whether it's conservative or not. So ratio of ADI or tolerable daily intake over TTC. And if this ratio is lower than 1, then the TTC is higher than the ADI. And if you have only the TTC value, if you had no experimental data available, you would under-evaluate the substance, and the approach would not be, the TTC approach would not be conservative for these substances. And I think that if we want to make the TTC approach, to make it something which is internationally recognized and for risk assessment, then we have really to try to work. That's one of the questions. I understood this morning that there are many more, but this one at least, we should work on this for to improve this situation. So this is the situation for the class 3 of Munro. So substances with, you have in the Munro in class 3, you have 449. 24 have a Psi ratio below 1. That is, if these 24 substances had been evaluated only with the Munro thresholds of 1996, they would be under-evaluated. But let us now apply the overall strategy of EFSA and the Creus proposal of 2006 and the overall strategy of 2012. Yeah. Okay. So we find steroids, a couple of steroids. As we have seen, they are in an exclusion category. You should not evaluate them using the TTC approach. You find polyhalogenated substances which belong to the group which may bioaccumulate, so they should not be evaluated through this TTC approach. And you find organophosphates and carbamates, which are another group now, and since 1996, another group has been defined for this, and they have a different threshold. So at the end, you see that of these 24 substances, only 7 do not belong to a structural alert group, not one exclusion category, and they represent 1.3% of the total database, which means that the substances evaluated in a conservative way, at least if you follow my reasoning, is approaching the 99%. So this gives confidence in the database. Another example of another database is for pesticide active substances. These are the pesticide active substances evaluated by EFSA till July 2013. 328 substances, many more were evaluated or but with the full data, 328, and with psi below 1, only 9. And which means that the ones evaluated in a conservative way represent more than 97% of the database. So these figures give confidence in the use of the approach. Of course, what we must do to improve this confidence is to better document the exclusion categories, to understand why substances which are among the 1, 2, 3, 4, 5%, where we have a psi ratio below 1, why these substances are there. Are they just outliers? Maybe we have to go back to the data. So a lot of work has to be done. We have to study, of course, larger database because we find more examples. And but my second take-home message would be that the TTC approach is really conservative in the vast majority of the cases. And there is more and more understanding about the reasons for the few cases where we have under-evaluation. This would be, in fact, my conclusion. I will just take together my two take-home messages. Number one was that for risk assessment, the TTC approach is often integrated in a strategy. That's what I have shown you on my third slide, making also use of data on toxicity and exposure. And take-home message two was that the TTC approach is conservative in the vast majority of cases, compared, of course, to ADI. Then we can challenge NDIs, but that's another story. So I want to some more information on the slides. Of course, the opinion of EFSA journal 2012, a book which is being published in the next months with Mike Cheeseman and Bob Safford, addresses more or less the same issues, but also in the area of cosmetics. And the data with the pesticide database is about to be published soon. And I thank you for your attention. I have put here two souvenirs. The first one is this one, which is a souvenir from Parma. Not many people know that in Parma you have this fantastic drawing of Leonardo da Vinci, which is more than 500 years back. And okay, that's for me a very strong image of Parma, of course with my former colleagues. But and my last slide would be from my personal event since exactly 1 week. I became the grandfather of this beautiful lady. So I take the opportunity to thank you again for your attention.